welcome back. Let's get into the last part of chapter 4 that we're going to look at, and that is this standard deviation measure of dispersion. So at the beginning of the chapter, we looked at dispersion via the range, which was the difference between the max and min value in the data. Another dispersion measure that we're going to look at now is called standard deviation, which shows how the values differ from the median, or mean, I should say. So a small standard deviation would mean that the data is clustered close to the mean, whereas a large standard deviation would mean more data values are farther away from the mean. So this is our definition. Statistically, S, the standard deviation, is equal to the square root of the sum of the difference of each element minus the mean squared. So I need the mean, subtract from each element, square that, add all of those up, divide by n minus 1, and then take the square root. So let's write some code or see some code that calculates this. And here's the algorithm. The first thing we'll do is find the mean. Then we'll have an accumulator pattern that looks at every value, computes the squares of the difference between the value and the mean, and accumulates that. Divide that by, should be n minus 1. So I think I have a typo in my slide here. That should say n minus 1. Take the square root, and then finally return the value back. So let's see how that works. Here is our definition for this. So first, find the mean. I can do that by using the built-in mean function. Now I have my accumulator pattern. So I'll set my total to 0 for every item in the list. Oops, don't change those. I want to look at that. For every item in the list, I take the item minus the mean, square that, and accumulate that into my total. After the for loop is done, then I take that total, divide it by n minus 1. So I did have a typo in my slide. It should be the len of a list minus 1. And then with the math module, take the square root of that. Finally return that back. So here we go. Here's my list with a mean of 12. My standard deviation for that, oh, I didn't define the module. There we go. Standard deviation is 4. Now if I have this list here with a mean of 12, its standard deviation is 8. So if we look at those two lists, they both have a mean of 12. The first has a standard deviation of 4. That means the data values are all clustered closer together, where here in this second list with a mean of 12 and a standard deviation of 8, that means the values are farther away from the mean. They're more dispersed. Look at the standard deviation of my earthquakes list. Is that floating point number, about 6.21. And I can look at the statistics module has a standard deviation, STDEV, and I get back the same answer. You could also change the mean if you want. If you want to provide your own mean to evaluate the standard deviation, you could do that. In this situation, I'm just providing the same mean as I had before, and I get the same answer. All right, that wraps it up for our Chapter 4 instruction. We will see you in class for our hands-on work.